Part 4 is about the theory of constraints, or TOC. This is just a very brief introduction to the theory of constraints. It was developed by Goldratt in his famous book, The Goal. Several more editions have come out since 1986, and a lot more has been added to his overall theory of constraints. But this book is an excellent read for anyone faced with trying to improve operations in a transactional environment. The goal itself refers to the goal of the enterprise, which is to generate profit. Profit is the result of producing goods quickly so they can be sold with the least amount of operating costs. So emphasis needs to be placed on increasing flow, and at any one time there's a bottleneck somewhere in your system, whether it's a production system, an order system, that's somehow cutting down on your flow. And so what Goldratt is saying is you need to have a set of tools for finding bottlenecks, eliminating them, and increasing flow. It's a lot more difficult than it sounds, but the concept is very sound and easy to understand. Anyway, as mentioned before, since the book was written, a lot more has been added to the theory of constraints. One of the theory of constraints concepts that I really appreciated that was written about in the book, woven into the story, had to do with eliminating bottlenecks but being hindered because resources were not being shared. And this was because of the way that efficiency was calculated within the company. There was no incentive to share resources, even if it would alleviate a bottleneck that would help everybody. Well, that's just one concept, but that, and along with the bottleneck concept and others, I would like to say that reading this book is probably one of the best things that a manager can do to improve their understanding of how to increase throughput, how to increase flow and reduce operating costs. Goldratt built a pretty good case against the over-reliance of some traditional cost accounting methods. He illustrates quite well how they can hinder improving flow and achieving the goal. I've created an example to try and illustrate a few of his concepts. We have a robot station, operation number 2, on the next slide. The operation is very efficient in cost per piece. It's very labor efficient, of course, because it's a robot. The company's cost accounting system shows that the process is very efficient, and it's highly praised. The problem is it can't keep up with demand. So the upstream operations are backed up with work in process, and the downstream operations are starved of parts, and therefore they're idle. So the robot operation is efficient on paper, but the plant efficiency isn't doing so well. Let's illustrate a bottleneck. Those of you that have production experience probably don't need this illustration. The robot operation is operation number 2. It can't keep up, and so in hour 2 it starts to back up, and it causes operation number 1 to back up, and it causes operation number 3 to run out of work to do. And in the shipping department, the safety stock is being depleted. Hour number 3, operation number 1 is totally backed up. All buffers are full. On the storage area, it's starting to back up because it can't move stuff to operation 1. And operations 3 and the shipping dock are starved of any work to do or products to ship. The bottleneck has caused the whole system to become dysfunctional. Let's take this illustration a step further. Suppose the plant manager is in his office and he doesn't know what's going out on the floor. He starts to get calls. The shipping supervisor calls complaining that he can't fill orders because he doesn't have any material to ship. The receiving dock supervisor can't unload trucks because the dock is full of inventory and there's no remaining storage space. The supervisor for operator 1 can't work because his buffer's full. The robot operation can't keep up, and the supervisor for operation 3 complains they can't work because they're out of stock. So, which one of these 5 problems should the plant manager address first? The point of that illustration is that at any given time, there is one constraining bottleneck that must be addressed, or all other efforts to increase flow are not going to pay off. So, part of the theory of constraints is being able to identify, that is to find, bottlenecks, realize what the best strategy is for mitigating it, letting the system settle out, normalize, and then find what the next new bottleneck is. And then, if you keep reducing bottlenecks, you'll keep increasing flow. But really what you're doing in the meantime is you're greatly reducing your operating costs and improving your true efficiency. The problem that Goldratt was pointing out is that many accounting systems, cost accounting systems, don't really facilitate this kind of problem solving because you have to cross boundaries in a rather radical way. Here are some common reasons for bottlenecks. This isn't a complete list, but I think you get the idea. Could be that you don't have enough capacity for output from your current tooling and equipment. Some of the things you can do is speed up the cycle time, work on reducing setup times. You might have to purchase new equipment or higher volume equipment. You might have some idle equipment that you can bring in, relocate to help you. You might have to increase overtime or move some work upstream or downstream, or maybe even subcontract. The point is that whatever it takes to get the bottleneck flowing is what you need to make sure that you aren't disturbing flow throughout the entire plant. Breakdowns can cause bottlenecks too. So you may want to consider some kind of a program to reduce breakdowns. That would be some kind of a program to improve reliability. Total productive maintenance systems are starting to become real popular because of this. Other causes of downtime could be absenteeism or tardiness. You may need to reallocate employees in order to cover bottlenecks. You might even want to consider an absentee reduction program. I know that may sound a little frustrating, but I remember actually going through and doing that at General Motors, and it helped. Anyway, reducing setup times, having backup equipment. One thing that happens sometimes is in order to expedite an order, sometimes work is stopped, the expedited order is run, and then what you leave behind is a catastrophe where a whole bunch of orders now are going to be behind and you're going to have to expedite them. So having a well thought out process for expediting orders is important, but what Goldratt's really saying is if you've got your system figured out properly, you're not going to have to expedite orders because they're going to get scheduled and filled right to begin with. Also, errors that could be the result of training and other things, work on those. And finally, human factors could be an issue with downtime. Sometimes people have trouble reading information and they make mistakes because of that. I remember when I was at General Motors one time they realized that if they just increased the size of the font on a lot of the paper that they used in the plant, they could reduce mistakes from putting the wrong parts on cars by about 50%. So anyway, eliminating downtime could be one of your biggest ways of eliminating bottlenecks. A very common reason for bottlenecks in a lot of companies in the area I live in is poor workflow. This is because a lot of companies are medium-sized companies that started out as small companies, mom and pop type companies, and as they grew, machinery was just put in this corner and material was stuck in that corner, and you end up with really very poor flow. So one of the first things to do is to streamline the flow, improve the layout. This could include rebalancing work, putting in material handling equipment, adding things like conveyors, carts, rollers, and other devices. And another thing that could be done is to reduce batch sizes. Sometimes people have large batch sizes and they hadn't even thought about reducing them. But if they did, it would improve their flow tremendously. The theory of constraints, in my opinion, aligns very well with Lean and the Toyota production system. It also applies equally well to service functions, whether you're talking about accounting functions, dealing with customers, or dealing with purchasing and orders. I think that these concepts can work very well in speeding up those processes. Actually, a lot of those processes are much harder to work on because they're spread throughout the company. They're not isolated in a particular production work area. So the theory of constraints could be a very valuable tool in helping improving those service functions. Final comment is that there are some experts that disagree with some of the TOC approaches, so you can do research on that if that's an issue for you.